So I'd like to introduce myself. I'm located in Raleigh, so very nice to actually be able to talk about Istio, my hometown. I've actually given many talks about Istio for the past 12 months, and very excited this is the first time to be able to speak in Raleigh. So this is our picture when we were doing a vacation in San Francisco, and we saw the boats, and I saw the bird. I was like, the bird looks like the Twitter icon, and the boat certainly looked like the Istio mesh icon. So I decided to use as the background of my Istio talk now. So, by the way, this is also the first time I actually speak without a computer in front of me. That makes me feel a little bit different. So what is exactly Istio? What are the problems Istio is trying to solve? Many of you are probably already in the DevOps journey to looking at have monolithic application and change to modern distributed architecture. So how many of you are actually looking at developing modern distributed architecture? Wow, lots of hands. So how many of you have heard of Istio? Wow, lots of hands too. So as your journey to modern distributed architecture, I'm sure you're looking at container-based services because container is the best method to package and also deliver your modern distributed architecture. You are looking at deploy that microservices into dynamic environments, and they are likely going to be composed through network. So a set of emergent problems arise as you kind of having modern distributed architecture breaking into microservices. So as the IT industry is shifting modern distributed architecture into microservices and distributed architecture, the set of problems arise as to how are you going to manage these microservices? How are you going to connect these microservices? How are you going to observe what are the traffics going on within the microservices? How are you going to determine which microservices causing you problems having your application not working? How are you going to actually apply policies to your microservices? And how are you going to secure traffic among your microservices? So these are a set of problems. You could solve it in one way, which is each of your microservices is going to handle all their problems within their application. But that's not going to be portable, and that's not going to be consistent, and you're going to left all the application developer to handle all that connect, observe, secure, and control problem to themselves. So you may not really want to do that too. So with this problem, the service mesh concept was born probably early last year. So the service mesh provides a transparent and language-independent network for connecting, observing, securing, and controlling the connectivity between the services. That's why people call it, it's a network for services, not a network for bytes. What service mesh really does is actually abstract the different pieces your application needed to connect, to observe, to secure, and control the microservices onto the platform layer so that the platform can solve these problems for you regardless what languages you are writing your microservices. And that's really neat because your developer doesn't have to worry about this, and then they can rely on the platform to provide a consistent way. So you're going to see consistency among how your services are connected to each other, how your services are going to be observed by the operator. So all that consistency comes with the platform. So Istio was a project launched last May by IBM, Google, and Lyft, founded by these three companies, but it's been tremendously growing. We have Red Hat was a big player in Istio now, and Cisco, and Tegera, Tetra, VMware. So it's a really thriving community. We have 200 plus contributors now. It's what's best about Istio is leverage the concept of service mesh, and it's providing an open service mesh platform to solve the connect, observe, secure, and control microservice problem. So your application doesn't have to solve that problem. Each individual developer doesn't have to solve it in their language specific way, and the service mesh provides the consistency for you. So at the core of the service mesh is really the four pieces we were mentioning: connect, observe, secure, and control. Hopefully you remember these four words. And the most important thing is also it's an open platform for service mesh. So how does Istio really works? Really quickly, since I think a third of you raised hand for having heard of Istio. So when the service needs A needs to talk to service B, so today they just call each other directly. When within an Istio environment, remember we talked about Istio as a platform is going to abstract all the key functions providing the network for services for you. So that's through the Envoy sidecar. When you deploy your service A and B within Istio environment, you would deploy a sidecar along with service A, which is really on the container A. So they are deployed within the same pod within Kubernetes environment. And also same for B. So container B, which makes up the service B, is going to be deployed within the same pod as the Envoy sidecar. Istio also has control plane. So on the bottom of the diagram, we're showing you the control plane. And then at the top is the data plane, which contains the traffic between your applications and the Envoy sidecar. So one of the key pieces of the control plane is Pilot. So what Pilot does is boots the configuration for your Envoy sidecar. So your Envoy sidecar would have the configuration as far as which services is my upstream cluster from an Envoy term. You know, how am I going to route my traffic? Which B am I going to talk to? The other key piece of the control plane is telemetry. So it provides the tracing, the observed problem we talked about earlier, tracing and metrics. So service A and service B, tracing at application level and metrics at application level can be sent through the Envoy sidecar to the telemetry component. And again, which is neat because the sidecar is doing things, so your application that has service A and service B doesn't have to handle about tracing. We also have a Citadel component, which is our security component to be able to assign identities and also enable secure communications among service A to service B. We also have a policy component to help enforce policies. So when A talks to B, it checks with the policy component to see, you know, am I really allowed to talk to B? So let's take a look how this works in the service mesh environment. When A calls B, A sidecar would intercept the call, so it doesn't go to the B directly. And then a sidecar, based on its sidecar configuration of the destination and also the route to determine, which exactly the B I'm going to send the traffic to. And when the traffic goes to B, it sends to the B's sidecar first, and then the Envoy sidecar on B is going to check, is A even allowed to talk to B? Am I going to allow the request comes through? So that's what the policy checks goes to, and then it forwards the traffic to B if it's allowed. And then when the response come back, it's come back from B to B's sidecar, tracks the traffic from Envoy. And then both of the sidecar also asynchronously report telemetry data. So it's reported to from A on the client side and B on the server side through the Envoy to the telemetry component of Istio. So if we put all that together, you can see at the top is how the data plane goes. So if you actually need to visit your application, most likely you're going to visit through Istio Ingress Gateway, which is another Envoy. You could also choose to visit your traffic directly through your service A using Kubernetes load balancer service or using node port within Kubernetes, but you will lose some of the function provided through Ingress Gateway, such as you won't be able to do traffic shifting or traffic steering from the gateway to service A. And then you can see the traffic goes to the Ingress Gateway to service A Envoy and then to service B's Envoy. And optionally, you can also set up an egress gateway to control your outgoing traffic going out of the mesh. One thing really notice interesting on this diagram is only from the data plane traffic, it only goes to the policy to do the policy check. And we don't go to the policy engine every single time because we do cache a lot of data on local Envoy. So most of the time it doesn't go to the policy component to check, but sometimes it does when the local cache doesn't have the data, such as is A allowed to talk to B. So where we are is still, Istio 1.0 was released in July, end of July this year. So it's our first production-ready releases. It doesn't mean every single feature is production-ready, but many of the core pieces are production-ready. We talk about 200 developers and the growing companies that's joining us on this journey. There's many adapters, and a lot of customers are actually using Istio. So the Istio in action at the bottom of the page are a list of the customers on different cloud providers using Istio. Some of the highlights of Istio 1.0 is you can flexibly configure Istio. Like if you don't need Mixer because you are worried about it goes to the control plane, Mixer component to do the policy check, you could optionally to install Istio without Mixer. So that's totally possible. You can do minimum Istio, just having Envoy sidecar and also the pilot component. So that's totally possible too. We have changed to a new traffic management model and new destination rule, new virtual services, new gateway to allow more flexibility of our network configurations. We have also have incremental mutual TLS support. So that's really important when you start looking into mutual TLS support within Istio. I highly recommend you start without mutual TLS and then use, once you get it working, and then gradually adopt a mutual TLS. It's much easier for you to troubleshoot in your application without mutual TLS. And then Istio provide very flexible way for you to enable it with just simple configurations. We also have Mixer adapter is out of processor now, so you could develop Mixer adapter to extend Istio. without rebuilding the mixer component of the policy component. So that's really nice. It actually resolved a lot of people developing more mixer adapters. We also had recently published our performance report. So if you're interested, send me an email. Be happy to provide that. It basically we have done a different performance analysis of Istio on different cloud providers. So give you some ideas on how much Istio is being added and how much resources being added to your application and your Kubernetes cluster. We also been released fixed packs. So 101, 102 has been out. It's been addressing some of the critical issues found by our customers since 1.0. It still has a lot of features, so a lot of our users are actually confused. When they started looking at Istio, when they look at our documentation, they find out overwhelming because we have a lot of features. I mean, it's a lot of problems we're trying to solve, from security to policy enforcement to resilience to traffic control and observabilities. So one thing we actually want to make sure our user knows that they can actually consume some of the features one by one. They don't have to consume all the features together. So for instance, weather company is a business acquired by IBM, I think 3 or 4 years ago. So they've been looking at Istio. They've been looking at deploy Istio in their production environment. And what they like about Istio is it's a single platform for many tools. It's significantly less code for them to write. And also, it's cloud native, it's cloud agnostic. So Amazon, I believe there's a couple of blogs on running Istio. There are companies, startup doing Istio support for EKS. Google has technical preview just lined up for managed Istio. Red Hat, I believe, just released technical preview also on Istio. So there's many of the cloud providers already support Istio. So you're not locked in when you use Istio. So the weather company was the example. They've been using Istio. They find out it really helped them identify problems among their 40 of their microservices, so they can quickly know which services has problems. It can also quickly allow them, through configuration changes, to be able to make sure they are testing the right thing, to make sure they are actually be able to change configuration, switch from different versions in development when they are doing their testing. So that's really powerful. So they feel confident about what they are testing and what they are running in the production environment. So one thing really interesting, I thought, in their scenario is they have 40 microservices, but they decided, I'm not going to move all my microservices into Istio. We're going to move one service at a time. So in fact, they only did one of their services in Istio mesh. So most of their services are actually outside of the Istio. It's connected to by services within the mesh to their external services. So they have using Istio gateway and virtual services to determine where the traffic goes, and if the incoming request can be handled by their cache generator, which is within the mesh, the cache generator will handle it. If it cannot be handled by their cache generator, they're going to forward to the external services, which is the current weather API. So from the current weather API perspective, they are not seeing, they didn't even know the traffic has been intercepted by Istio, has been intercepted by the cache generator. So that was really neat from their perspective on that. And this is a simple service entry. I'm sorry, the fonts may not be super friendly, the color, but it shows their service entry to bring their current weather API as an existing service outside of the mesh into the mesh for consume. And this is their simple route rule. You can see how they have cache generator, intercept the traffic, and also rewrite the traffic to do a URI match on the rewrite. Another company we're working with is a large airline company. They are deploying Kubernetes cluster on our IBM cloud, and they're looking at Istio to leverage traffic management to do request routing. They use Istio to do circuit breaking, route rules, so they can control the traffic to do traffic steering, traffic shifting, and also traffic monitoring to look at their services to see, where the services has problem, where are the latencies, what are the delays of their services, and to apply policies on the ingress and egress layer so they know exactly what are the traffics goes into the mesh and what the traffic goes out from the mesh to the external worlds. So let's see it in live. So I'd like to introduce quickly on the application. So the application we decided to move to the mesh was a popular Kubernetes guestbook example. How many of you installed Kubernetes guestbook? It's one of the most popular Kubernetes guestbook Kubernetes example as we were learning Kubernetes 2 years back. And what's interesting about this example is guestbook version 1 is pretty much what comes from Kubernetes. We didn't make any changes. And then guestbook version 2 is what we did to make it different. So we decided we're going to consume external service, which is a tone analyzer service from Watson. So as the user leave guests, leave messages on the guestbook, we're going to automatically, based on the tone, we have a little bit of code to generate an emoji, so you actually make it fun to see the messages. So with version 2, we added, we enhanced the guestbook service, and we added the analyzer service. And what's also interesting is you can see we also have services running outside of the mesh. So like in this example, the Redis slave and master, they're running in Kubernetes, but they are running outside of the mesh. So since I don't have access to a laptop, so we'll have to do a recorded demo. So I apologize for that. Not my first choice, but I just recorded this an hour ago, so it's still pretty fresh. What we are seeing is you can see all the pods within the Istio system. So you can see I have the Istio control plane pretty much installed with a bunch of optional components like tracing and Grafana is also there too. You can see I deployed the guestbook version 1 and version 2, and also the analyzer, and Redis is also there too. So if you do istio-ctl get all, that would shows you all the configuration within the mesh. So you can see I have a destination rule, my virtual services, and guestbook gateway. So let's take a look at the guestbook gateway and see what it looks like. So the guestbook gateway essentially declares what is my host, what is my port, what is my port number, which is 80, and I'm using HTTP as the protocol. So let's take a look at the virtual services. So we have a virtual service called guestbook, virtual service guestbook, and it's the virtual service bind to the guestbook gateway we just look at, and the destination is simple, it's just the guestbook destination. So now we're going to look at the destination rule for the guestbook. As you can see, Istio configuration, you're pretty much using kubectl to handle most of the configuration objects. So it should be very native for folks come from Kubernetes. So the guestbook basically right now configs a round robin between the services as the destination rule has. So you can see it's basically route to version 1 and version 2, and it's a round robin. So nothing really interesting, but it would shows you, it give you 50% of chance to goes to version 1 and 50% chance of goes to version 2. So now we are visiting the Istio, the guestbook through the Istio gateway. And you can see .58 is my gateway IP. So what we are doing is we are leaving some messages onto the guestbook. Now you can see, I'm leaving a message without, now I'm leaving a message, okay, the guestbook analyzer was attempting to analyze the tone, but it didn't find any tone. So let's take a look at what's going on. So remember we talked about Istio provide metrics and tracing. So what we are doing is we set a port forward to the JGA port. So we can actually look at the JGA UI to do a little bit debugging. And you can see we are looking at the traces from the guestbook services. So every single request to the guestbook services will be recorded here. So you can see I visited about 20 traces from that looks like today. And if we go to the analyzer services, so the analyzer services, I have 2 arrows. I have a single request coming. So you can see from the text of the particular arrow one, oh, we actually got a 500 arrow on the analyzer services. That's probably why it must have trouble to connect to the Watson tone analyzer service. So Istio has service entry. When your services within the mesh needs to talk to services external, you actually have to config the service entry object to bring the external services into the mesh. So this is a service entry config we are going to apply. So it basically allows gateway.watsonplatform.net on this particular port number, allow the traffic from the mesh to goes to. So now let's apply the service entry. Now let's try to do another message. Hopefully we'll be able to get the tone generalized now that we actually apply service entry correctly. So as you can see now we do have the emoji generated. So the service entry was important as the operator of the mesh to allow the microservices developer to say, these are the traffics I'm allowing to access, and these are the traffic I'm not allowing to access. So let's take a look at how do we do header-based testing. Because I can do round robin with guestbook, but that's not really interesting because 50% of the chance I'm testing version 1, there's no tone analyzed. But if I want to do a little bit of round robin testing, like this virtual service destination configuration would show you, for Firefox, it always goes to version 2, and then all the other traffic goes to version 1. So let's check it out, see if it works. Now we're heading through Safari. You can see I'm always getting to version 1. So let's bring up Firefox hopefully soon. So this is my Firefox window. And what we are doing is try to visit the guestbook. So you can see I'm always on version 2 now, and I can be confident it's always going to be version 2. So if I actually leave a message, go back to Safari, and if I leave a message, it's just not going to be analyzed, and I'll be confident that now if I go into Firefox and leave a message, I got my tone analyzed. So that's really nice with the virtual service test configuration, because I know exactly what I'm testing. Now, if I feel confident about what I'm testing on version 2, now what we are going to do is we can do canary testing. We can say, hey, I want 80% of my traffic goes to version 1, and I want 20% of traffic goes to version 2, because I'm gaining confidence about my version 2. So now if you go back between Firefox and Safari, you can see it's flipped between version 1 and version 2, but version 1 actually have a much higher chance as we config. So this is really nice to be able to do canary testing with single configuration without changing your Kubernetes pods replica. So what we are going to do next is we want to bring up the Istio dashboard. So I unfortunately made a little bit of typo here. So what we are going to do is to bring up the Grafana to do a Kubernetes port forwarding to be able to reach out the Grafana dashboard. So let's get the right command in the command prompt. And you can see we should be able to visit now on the port 3000 with the port forwarding. So this dashboard is provided by Istio without you needing to do any actual work. So with this dashboard, you can actually look at your services deployed within the mesh. You can look at the successful rates. You can look at your client request volume, your server request volume. You can do response. You can have an analysis of all your response code, all the incoming requests by different source. So all this data are available for you, provided by platform, and it's in a consistent way for your services deployed within the mesh, and you don't have to actually do any code for this. So that goes back to what we talked about earlier on, the platform to provide a service mesh platform for network for services provides you the everything, abstract everything onto the platform layer so the developer doesn't have to write code to do traffic shifting, to do traffic routing, to do observe your microservices, to do tracing, and also to do the metrics. Now, if we can go back to the deck. Thank you. So what you have seen service entry, configure service entry as the mesh admin to control what external services your microservices can access to. So without the service entry, your microservice is not going to be able to access a service outside of the mesh, which is the Watson tone analyzer in our example. You have seen the access the guestbook through ingress gateway. You have seen we apply traffic management. We apply dark launch over version 2 of the services. You have seen we do 820 canary testing of our version 1 and version 2 through Istio traffic configurations. You have seen distribute tracing, JGA UI to help us troubleshooting the problems. You have seen Istio mesh metrics through the Grafana dashboard. So Istio 1.1 and beyond, the community is very actively working on Istio 1.1. We are trying to make Istio easier to use and adapt it, so that's actually a constant theme on our mind. We want to continue on our journey to allow users to incrementally adapt to Istio to publish around. The functionality is already there, but the documentation are not super friendly. So we're trying to make sure user knows how to incrementally adapt to Istio. They can consume what features they want, start from there. We want to Mixer, because the call to Mixer has sometimes are part of the control plane call. You have to go back to Mixer. So we are looking at allow user to run Mixer per node as a daemon set, or even run Mixer as a sidecar so that you don't have to have the actual policy call go back to the control plane. Another thing the community are very actively working on is multi-cluster. How do we do multi-cluster Istio mesh, and how do we do federated Istio mesh along multiple environments? And performance and scalability are always a focus for us, and we are continue to do enhancement on that. There are different measurement on what are the sidecar latency, what are the startup time of the sidecar, and we'll continue to focus on that. Bug fixes and integrate with API management are the other things we are very interested to focus on. Minimum Istio, so the documentation is already out there. If you're interested in to run Istio without mixer, without security, you can do that even without tracing. So if you just want to test some traffic, be able to shift your traffic through a configuration, be able to steer your traffic, that's the profile we recommend you to use. We also have multi-cluster single control plane that's out there. We are currently working on some of the limitation of this design so that you don't necessarily to have flat networking, routable networking between your pods on multiple clusters. So stay tuned. We're going to enhance this to reduce the limitation. Now it also requires 2 cluster has different CDAP block, which some of the cloud provider has the same CDAP blocks. So the other thing we are also doing is federated Istio mesh through the gateway. So your cluster, each of the cluster has their Istio control plane, and they can retain the cluster boundary. And then they have federated Istio mesh through the ingress and egress gateway. So with that, I highly encourage you guys to try Istio, and hopefully you are going to give us a feedback. There are developer mailing lists and user mailing lists down there. Our website, our community project on Git is all up there. And I'd like to open up for questions if you guys have any. I know it's between lunchtime, so if you have any, I welcome, or you can feel free to connect me after the session too, if you feel too shy. Thanks, everyone. I appreciate it.